Okay, so asymptotes are something that we talked about quite a bit in Algebra 2. I would say we spent most of our time talking about vertical asymptotes. Today I'm going to talk about how algebraically we can find vertical asymptotes, okay, on a graph. Horizontals are a little more complicated, and we're going to officially talk about that next chapter when we do like rational functions, but I'll just touch on it today. But for today, if you're doing horizontals, you can look at the graph and kind of tell. All right, so there's two types of asymptotes. We have vertical and in our notes, what I would like you to write about vertical asymptotes is the way that you find them is they are zeros of the denominator. Zeros of the denominator. What do I mean by that?
The x in the step.
Nope. Those are zeros of the numerator.
It's what makes the bottom equal.
Yeah, it's an x value that would make the denominator 0, and sometimes there can be more than one. And the reason why they're an asymptote, is because they are a line that the graph actually doesn't touch. And so hopefully it makes sense then that they're undefined at that point. All right, there's a lot of extra talking going on. Then there shouldn't be. Okay, so they're the zeros of the denominator. The way that I would like you to write the asymptote is I would like you to write it as a vertical line in the form x equals. Okay, and I know there were the functions undefined, but it's like we're pretending what would that vertical line be. Okay, so x equals would be the form for that. So that's vertical asymptotes. Okay, horizontal asymptotes are for now I'm going to tell you to look at the graph, but I'll tell you the little deal with those, okay? So we're going to look at the graph. And all I'm going to tell you for the function is you're going to compare the degree of the numerator versus denominator. Okay, so what I will tell you, and I don't know if some of you remember this from Algebra 2, is another name for horizontal asymptotes is sometimes they're called end behavior asymptotes. And their end behavior is what the ends, by ends I mean as you get far to the right and far to the left, are there values that the ends of the function approach, okay? Meaning approach, an asymptote is a value that the function approaches but it never reaches. So the reason why sometimes these are called end behavior, and think about if you remember this from last year, is sometimes we get these functions and they would cross in the middle. Do you kind of remember this? No? They'd cross in the middle, but then at the ends they'd approach this like horizontal line. Okay, so that's why they're sometimes called end behavior, and that's where that term comes from. We'll look at one today. All right, so let's do one. And We're going to look algebraically, and then we're going to look at the graph. We'll see what you remember. So let's take a look at the function f of x equals x over x minus 3. Okay, and let's see who remembers this. What's the degree of the numerator? You can just show me with fingers. What's the degree of the numerator? Numerator, degree of the numerator. Degree is 1. What's the degree of the denominator? 1. Okay. The reason, this, again, if you don't remember this from last year, it's okay. I'm going to have you look at the graph. Here's what I mean by compare numerator and denominator. You just told me degree 1, they're the same degree, correct? Oh, I don't have any Jolly Ranchers left. I got to order them. I was going to say for a Jolly Rancher, can anybody remember when the degrees were the same, what the horizontal asymptote was? How did you get that?
I just remember that.
It's leading coefficient. You divide the leading coefficients. So 1 divided by 1. It would be y equals 1 here. Yeah. But we're going to look at the graph and we're going to look today. Verticals. Verticals I don't need any fancy formula for. Look at the denominator. What do you notice in the denominator?
There's a -3.
There's x minus 3. What x value would make the denominator 0? 3. So I'm going to write there should be a vertical asymptote, and that is at x equals 3. All right. I told you, so when the degrees of the numerator and denominator are the same, if you remember from last year, great, you take the leading coefficients, which are 1 and 1, and you divide them. 1 divided by 1 is 1. There is a horizontal asymptote at 1. If you don't remember that, you're going to just make your best estimate from the graph. So if you're using Decimus, great. If you're using graphing calculator, you do need to use a denominator on the x minus 3 on the bottom.
Don't you have the alpha, like, fraction key?
I don't know anything about the fraction key because I never use it. Sorry.
You're good.
Do you see the vertical asymptote at x equals -3? Okay. Do you see how this function is going up, but it's not crossing a value horizontally? Same thing over here. And it's definitely above 0. All right, I'm going to go ahead and plot y equals 1 so you can now see. All right, so it's not going to cross 1. Okay, so we're going to write down then. There is a horizontal asymptote of y equals 1. So horizontal asymptotes are written as horizontal lines. Okay? And then the last thing I'm going to show you is a new notation. So this is going to be new. And here's what I will tell you about it for now. You just need to be able to understand what this notation means and answer the question. So what I'm going to do is I'm going to write this horizontal asymptote as end behavior. What do I mean by that? Do you see as I go further to the right forever and ever and ever that it's not going to cross 1? That's the end to the right and the end to the left, the same thing. Agreed? So the way we write that is, what is the limit? Limit, we write LIM. As x goes to positive infinity, just write it down. So that means, what's the limit of the function as x goes positive infinity means to the end to the right, okay? What is the function or the y value go towards? It's going to be the same as its horizontal asymptote. So it's going to be 1. Okay. That's going to the right. What is the limit as x goes really far to the left? So what do you think I'm gonna write? X approaches
Negative infinity.
negative infinity. So all this portion means is, what is the function approaching? The limit part means it might not get there. It's gonna approach some limit, some value. And we agreed that also when I went really far to the left, the function also approached 1. Okay. I think I didn't use that word limit last year. I think we used X arrow and Y arrow. But now that we're getting to be better mathematicians, this is a notation that probably you should recognize. Yes? Yeah, limit notation. And calculus, we use it a lot. So it's an introduction today. So something new. This is what I'm referring to when I'm referring to end behavior. Okay. Well, let's see what we got today then.